Good afternoon. I'm pretty loud, so I don't need mic. So that's what my wife always complains. Good afternoon. Thank you for the introduction. And firstly, I would like to thank the organizers for inviting me to give this presentation. It is a great honor to share my research work with you. The title of my presentation is Characteristics and Ecotoxicity of Microbeads, which I call microplastic or particulate plastic in terrestrial and aquatic ecosystem. You can see in Australia, around 1.58 million tons of plastic materials are used annually. For example, Australia uses 6 billion plastic bags per year. We have only 20 million people, we use 6 billion. It's not million, 6 billion annually. Recently, China banned import of recycles, including plastic. That has created shock waves in many countries, including Australia, New Zealand, and many European countries. So we wrote a paper. This is the article me and Dan Sang wrote. That's called Step In, which is Innovations in Solid Waste Treatment for Environmental Protection. So this work is one of the outcome of that article. This is the outline of my presentation. So briefly, I introduce particulate plastic in the environment. Then I will talk about the impact of particulate plastic in the environment. I interchange particulate plastic, microbeads, microplastic, nanoplastic. It is a continuum. Then I will talk about the research project, which I will cover two aspects. One is the sources of plastic in soil, just following on our previous presenter. How much quantification. Then I will talk about ecotoxicity of particulate plastics. Then I will talk about the outcome of our research and then brief some conclusion. Now let us look at the particulate plastic in the environment, how it reaches the environment and what are the issues. Now this is the global production of plastic, 335 million tons per annum. And this is the plastic waste in Australia, around 450,000 tons per year. I couldn't get hold of how much Korea produces, but this is what I got. Just 1 month, January, February 2017 to January, February 2018, the plastic import has tripled from 3,800 to 11,000. This is just in a month. So, and they all come from those countries. You can see that it's all imported all the way from, Japan, Netherlands. They all come to Korea. Huge volume is coming into Korea. But what is the good thing is, Korea will reduce plastic waste by 50% and increasing the recycling rate from the current 37% to 75% by 2030. If I'm alive, I will be able to see whether they do that. So that's what the plastic issue is. Now, particulate plastic in the environment. There are two major sources. One is called primary particulate plastic. These are the ones we use in cosmetics. Just now my colleague told us that Korea has already banned, but Australia still continues to use. Then we have a secondary particulate plastic. These are the macroplastic. A good example is plastic mulch. And the plastic mulch, it weathers, it reaches the soil. Majority of the time they don't collect it back. It's very expensive to collect it. So they just leave it in the soil. So these are the two sources. Now let us look at how it reaches the soil. Recycled water, exactly you are right. Biosolid, compost, and plastic mulches are the major sources of plastic reaching soil system. From soil, through erosion, it will go to aquatic system. Erosion is one of the main input of plastic from soil to aquatic system. Although majority of the soil plastic are segregated during the composting process, the significant portion which include microplastic, now they call it nanoplastic, will end up in the compost. So when you put it in the soil, it goes back to the soil. So this is how plastic end up in the soil. Now let us look at what is the impact of plastic. So when plastic is introduced, what will happen? Now, plastic input into terrestrial ecosystem, which is soil, can have both beneficial and detrimental effect. People don't like when I say beneficial, but it has beneficial. I'm a soil scientist. We all know that polyacrylamide is a plastic. We use it for flocculation to control soil erosion. But it's a soluble plastic, it's not a particulate plastic. The particulate plastic can serve as a hidden source of carbon sequestration. I'm not proposing you to add plastic to soil to sequester carbon, but it can be a carbon source. But the most important effect is plastic serves as a vector for the transport of contaminants. And that's where the real issue, the mobility and transport of contaminants by plastic. Now let us look at the research project. There are two topics I'm going to cover. One is the sources of plastic, the other one is ecotoxicity. The sources we quantify. So although particulate plastic input to soil is an emerging issue, I didn't say emerging contaminant issue, it is an emerging research issue. Their sources and impact on soil environment remains largely unclear. A lot of work on aquatic marine system, not much on soil system. So therefore, we aim to quantify the amount of particulate plastic input to soil through bio-waste, biosolid and compost. Then we want to examine the effect of these on ecotoxicity in the soil. We use microbial activity in aquatic system. We use Daphnia test, very commonly used. Now, particulate plastic is extracted from a number of biosolid and compost samples. Pristine polyethylene, which is a plastic. Particulate plastic extracted from biosolid, because that is extracted from biosolid, sediment and soil. That's the pristine one. We pipe the microbeads into this material and extract it for our ecotoxicity test. The moment you spike them, you can see that they get the color of the medium. I will explain why. Then we also use a plastic to which we added copper. So we use pristine and the plastic extracted from soil, sediment, biosolid, and one treated with copper to look at the ecotoxicity test. This is how we extracted. The microbeads were extracted from these samples using barium chloride and also water because they have a different density. So we separated into density fractions. The simple technique is sieving, density fraction, and filtration. That's the simple technique. Now, properties, characteristics. These were characterized using SEM, EDAX, and FTI technique to look at some of the functional group. The ecotoxicity, we use two tests. One is soil respiration, very commonly we use that, and also we use Daphnia motility test, what we call immobilization test. Very commonly used to look at aquatic toxicity. You can use, the best thing is to use fish, but require a lot of risk assessment, and so Daphnia is a very simple test to do that. Now let us look at some of the results. But then I will go back. This picture is nothing to do with Australia. Okay, so don't worry, it's not happening in Australia. Now let us look at quantification of particulate plastic. This table gives the shape, water extraction, and barium chloride extraction, total number. So you can see that they have all different shapes. Fiber, you are right, and different hexagonal, spherical, trigonal, cubic, all kind of shapes, and also different. So biosolid tested contain a range of particulate plastic. That's the size range from less than 50,000 micrometers. So that's a huge range of size and shapes of particulate plastic. But you can see in Australia in 2017, we produced 327,000 tons of biosolid. In Australia, 75% of the biosolid is used for soil application. I believe in Korea it's completely banned. In Australia, the soil has the capacity to take control of the biosolid because the heavy metal concentration of biosolid is very low. We very commonly use biosolid for soil application, a very good carbon source. But what is amazing there is you can see that around 240,000 tons of biosolid is used. The number of particles is 220 billion particles are reaching the soil system. It's all about number games. You can see the next slide is all about numbers, not the mass. So you can see this table gives the various bio-based, biosolid, green-based compost, manure compost, food-based compost. Then there's the number of particulate plastic, the weight per kilogram, this is number per kilogram, and the input to soil on the basis of 10 to 20 tons of compost application. So we add up to 20 tons of compost. So when you add 20 tons of biosolid, how much particle entering into the soil system? So you can see that biosolid has the highest number, whereas manure compost has very low. Majority of the manure compost comes from cross-contamination when we are processing the manure. But however, if you go to India, this is what happened in India. The cattle literally eat plastic bags. So the manure can contain plastic bags. It's very sad, but that's the reality. I was in India a couple of months ago, that is the issue there. So if you look at, because the plastic, weight of the plastic is very light. So therefore, as a weight, as a mass of plastic input to soil is insignificant, 0.15 to 1% of the bio-based addition. So if you add 10 tons of bio-based, it's only less than 1% of that will be particulate plastic. As a mass, it is insignificant because the weight of the plastic is very, very light. However, if you look at the number of particles, 5 to 12 million per hectare, that is the number of plastic getting into the soil when you add 10 to 20 tons of biosolid. Now, these are some of the properties of this particulate plastic. You can see this is the FTR spectrum. So that's for the pure pristine plastic. This is the plastic extracted from biosolid. So the message is the major peaks for microbead match with the peaks of the pure material. So you can fingerprint using this technique. And this is IR spectrum. Again, the spectrums can be used. The IR spectrum for pristine microbeads is similar to that extracted from soil, sediment, and biosolid, provide a fingerprinting of this technique. Then we look at SEM and some elemental analysis. This is the SEM. These are some of the elemental peaks. It's not very visible, but if you look at the next table, it gives all about these elements. So this is biosolid, sediment extracted, soil extracted. The elements, when you extract microbeads from these sources, these are some of the elements. So when you go back the picture, remember, when you add microbeads into soil, it get the red color. So that's because the microbeads take up some of the elements. So the microbead extracted from soil, sediment, and biosolid contain a number of elements indicating their association with microbeads. So they become a carrier of these elements, what we call vector. That's what I'm going to explain in detail. So this is, we talked about the characteristics. Now let us look at ecotoxicity. This gives the respiration at various concentration of microbeads and microbial activity. This is for the copper treatment and also soil extraction. We also give, so that's the lethal dose, effective concentration at which the respiration is reduced by 50%. So soil basal respiration was less in soil treated with copper contaminated microbeads, suggesting copper toxicity to soil microbial activity. We all know very well copper is very toxic to microbial activity. So plastic can carry the copper and make it toxic. It is the chemical associated with the plastic which are the copper. This is the motility test, immobilization test of daphnia. Again, with increasing concentration, this is the immobilization of daphnia. The immobilization increases or the motility decreases. So the daphnia motility was less in the presence of copper-treated microbead, indicating that microbead acts as a vector by heavy metal toxicity in aquatic ecosystem. So it is the effect of microplastic or particulate plastic acting as a vector. So now let us look at some of the conclusions. What are the conclusions derived from this work in relation to quantification, characterization, and finally ecotoxicity? Number one, particulate plastic reaches soil environment through compost and biosolid application and also through the use of plastic mud. Number two, microbeads have the ability to absorb chemicals that are toxic to organisms. Copper is a good example. Plastic can cause both direct and indirect toxicity to terrestrial and aquatic organisms. But this is the most important one. Plastic can serve as a vector for the transport and mobility of the inorganic, which is heavy metal, and organic, a good example is PAH, contaminants. So it is all about the vector. This direct toxicity of plastic is less, but it acts as a vector for contaminant. So let us just look at quickly the vector theory. What is the vector theory means? This is the pristine particulate plastic, and that's the particulate plastic with dissolved organic carbon. The moment it enters the environment, it takes up the dissolved organic carbon. So this is the pristine plastic, which is hydrophobic, and hence it repels inorganic ion like copper in soil solution. So it doesn't take the copper, the pristine plastic. However, so it doesn't like copper. But when plastic is introduced to environment, it attracts, it's an organic compound, it attracts organic compounds like dissolved organic compound. So that's the pristine plastic. So it takes up on dissolved organic carbon, dissolved organic carbon complexes with copper. So therefore, it acts as a vector. So what is the take-home message? The take-home message is, this is what Donald Trump will say, I'm repeating this many times, there are known knowns, known unknowns, unknown unknowns. He was the former defense minister. It's very difficult to understand what Donald Rumsfeld says or Donald Trump says. It's very difficult to understand. Nevertheless, perhaps there are more unknown unknowns in the distribution and ecotoxicity of microbeads, microplastic, or particulate plastic. The take-home message is particulate plastic can act as a vector of contaminant transport, thereby resulting in terrestrial aquatic toxicity. Finally, I would like to thank my past and present student who done this work. Thank you very much. It's exactly 19 minutes, 58 seconds. Thank you.
Do you have any good method in extracting and detecting microplastics from soil?
This is the real challenge. We are, I think most of the people are using density fractionation, and we are using a lot of density fractionation, like clay fractions, heavy clay fractions. But there is no standard method yet. That's one of the challenges to develop standard method. Perhaps you can provide some funding for my student.
Please.
Yeah, one more question.
Thank you, Nanthi. Very interesting talk. So, you hear me?
Yeah. I'm still deaf, but I can hear.
Okay. So, you didn't really mention organics in terms of organic contaminants, particularly. But I wondered if you thought, or people have done some experiments regarding absorption of pesticides in plastic-laced soil. One would think there's opportunity to build bound residues for those pesticides.
It's a very interesting question, Brian. In fact, the issue with organic contaminants is more than the issue with inorganic contaminants, because plastic is organic, they don't like inorganic, so they really attract organic compounds. A lot of work is done in marine system, but not much work on soil system. It's a great opportunity. I didn't show, we did some work with PAI, I didn't show much, but there's a lot of potential to look at plastic as a vector carrying organic contaminants. This is exciting. But as you can also do some. Thank you.